All right, and we are back. We're going to now be talking about the second half of 1.2, which is all about functions. Specifically, we're looking here at linear functions. So let me just get up the pen and we can get started on this one again. Okay, so linear function is basically defined as a relationship between two variables that gives a straight line when we graph the points. The maximum exponent of the variables in a linear function is always 1. So if we see here y equals x squared, well, let's have a think about it. This does not have a variable in it. So you might be tempted to say that this is not a linear function. However, it does have x to the power of 0, which is just equal to 1. And it is the fact that the maximum exponent is 1. So given the fact that we don't actually have any values of x here, we would define this as a linear relationship or a straight line relationship. This one here is more obviously a linear relationship. We can see it's always going to be of the form y equals mx plus c, where m is the gradient, c is the y-intercept. So here we've got a gradient of 1, a y-intercept of 3. It's linear. You can see the highest power of x is 1. If there's no power written up the top there, it just means to the power of 1. And by contrast, we have something that is not a function, or sorry, not a linear function, because we have x squared. The highest power of x here is 2. Therefore, this is a quadratic and not a linear equation. Okay, so to sketch a linear equation, all we need is 2 points. So once you have found 2 points, these could be the x and the y-intercept, we can graph the entire function by continuing in both directions. So if this was 1 point, this was another point, I could continue the line in both directions. That would be the line. Notice that I wouldn't draw it like this. I wouldn't just draw a line segment. It needs to continue forever in both directions. Don't make that mistake. All right, a linear equation is also defined by the fact that they have a constant rate of change in x with respect to y, and this rate of change is called the gradient. So let's say, for example, you're driving along a freeway, and you're driving at a constant speed. So in the first hour, you're going to travel 100 kilometers. So let's say this is time in hours, and then this is distance in kilometers. In the first hour, we're going to travel 100 kilometers. And then in the second hour, I'll wait until that one's over. In the second hour, we're going to travel another 100 kilometers. So all up, we've traveled 200 kilometers. And we can see that it's going to go up 100 every single time. So therefore, this is a constant rate of change. We can see that it traces a straight line. All right, so to calculate the gradient given 2 points on a line, let's say we have the 2 points x1, y1, and x2, y2. We just need to use this formula rise over run. So we can see that the difference between the x values is going to be the difference x2 minus x1. So this value minus this value, that's the distance across here. And this value, y2 minus y1, y2 minus y1 is going to give you the distance between these two values. So we have the formula here, rise divided by run is equal to the gradient, which is m. So that's an important rule. Once you know m, you can then use this formula here, which is called the point gradient form of a linear equation, to write the equation in standard form. So we have y minus y1 is equal to m times x minus x1. All right, a few rules that you need to know. If two lines are parallel, they will have the same gradients. If two lines are perpendicular, the product of their gradients will be equal to -1. So for example, m2 times m1 is going to be equal to -1. That's a couple of rules we need to know. Next thing we need to know is that the gradient is the same as tan of theta. And we can see that up here. We can see this is an angle. So the angle with respect to the positive x direction. If we think about it, these 2 points form like a right angle. So we can imagine this is a right angle here. And like we showed before, the opposite side of this right angle is y2 minus y1. The adjacent side is x2 minus x1. So therefore, we could look at this as a right angled triangle where we have, okay, let's just label the sides of this. This is the hypotenuse. This is the opposite. This is the adjacent. we don't know anything about the hypotenuse yet. So we can look at this as we have O, we have A, so therefore we're going to use the relationship tan is equal to O over A. And O is equal to y2 minus y1, A is equal to x2 minus x1. So therefore, we could just write this as tan theta is equal to opposite over adjacent, which we can write in that form there. So, and we know opposite over adjacent, so rise over run, that's just the same as gradient. So therefore, the gradient is equal to tan theta, where theta is the angle made with the line and the positive x direction. All right, now moving on, we have horizontal lines have the equation y equals c, where c is a constant. So if you see an equation written in this form, y equals 3, for example, that basically just means that no matter what x is equal to, y is equal to 3. Let's have a look at this on Desmos. It's a bit easier than drawing it by hand. So let's look over here. We have Desmos. I'm just going to type in y equals 3. Look, it's a horizontal line. So no matter what the value of x is that we put in, we get out a value of y. Y equals 3, regardless. This is a function. It is a function that is always equal to 3, but it's still a function because it passes the vertical line test. Yeah. In contrast to that, the equation x is equal to 3 is not a function because it definitely does not pass the vertical line test. It is, in fact, a vertical line. It has infinitely many solutions. So if I put in, like, there's only one x value I can put into this function, it's 3. And I'm going to get out an infinitely many number of y values when I do that. So this is definitely not a function. Okay, so that's what we looked at here. Now, if a line is neither horizontal or vertical, it is called oblique. This is a word that you might see. All you need to know is oblique just means it's not horizontal, not vertical. So it's just any other line, like that one, for example. That's an oblique line. Moving on. So the last thing we need to look at is midpoint and distance between points. So let's suppose we have points A and B. The midpoint is basically the average of the x coordinate and the average of the y coordinate. So if we add the two x values together and divide by 2, and we add the two y values together and divide by 2, we're going to find the coordinates of the midpoint. So this is a formula that you will need to use. And then finally, if we have the distance between 2 points, D, so this is D here, we have x1, y1, x2, y2. The distance between those 2 points, well, we can imagine this as solving if we construct a right-angled triangle between these 2 points. What we're basically trying to find is the hypotenuse of that right-angled triangle. So like we saw before, the two non-hypotenuse sides are going to be x2 minus x1. That's this side here. And we have y2 minus y1. So if we put this into the form a squared plus b squared is equal to c squared, and c is d, the distance of this line, so the length of that line, the magnitude of that line, whatever you want to call it, we have this relationship here. And if we square root both sides, we end up with this relationship here. So d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so a couple of quick questions. Let's say we have these 2 points. Let's see if we can find the midpoint. So the midpoint, that is just going to be equal to, let's use blue for this because I've used too much red and it kind of hurts your eyes a little bit. We have m is equal to the average of the two x values. So the x coordinate is going to be -3 plus 4 divided by 2. And then the average of the two y values. So we have 5 plus -6 divided by 2. So if we have a look at that, -3 plus 4 is going to be equal to +1 over 2. And 5 plus -6, that's going to be equal to -1 over 2. So that there is the midpoint between those two lines. So the midpoint between those two coordinates. All right, now let's try the distance between these 2 points. So let's have a quick look. We have the points. I'll just write them down here so I can see them on the screen. We have -3, 5, and we have 4, -6. So all we need to do here, substitute those values into this formula. So we have the Pythagorean identity. Be careful that you're looking at the same two types of values. So it's x2, this is x2, this is y2, this is x1, this is y1. Doesn't matter which one we call 1 or 2, so long as you're consistent. So we have y2 is going to be negative 6 minus y1, which is 5 squared, plus x2, so that was negative 6 minus 5, yep. Plus we have 4 minus negative 3 squared. Now, this bit here is going to be, so that's negative 6 minus 5, which is negative 11. So we have negative 11 squared plus 7 squared. That's going to be equal to 121 plus 49. I'll have to stop this pretty soon. All the announcements are getting in the way. That's going to be equal to 121 plus 49, that's equal to, what is that? Can't do basic maths. 160. Pretty sure. No. 170. 170 that should be. Hey guys, what's up? Oh, that's all good. So I'll stop this.